Welcome to the solutions manual. In this video, we will solve the problem 1-4 from RC Hibbeler Mechanics of Materials 10th edition. According to this problem, the shaft is supported by a smooth thrust bearing at A and a smooth journal bearing at B, and we have to determine the resultant internal loadings acting on the cross section at C. So to solve this problem, first of all we have to draw the free body diagram of this shaft. At point A, we have a thrust bearing, and for the thrust bearing we have two support reactions. So we have a support reaction perpendicular to the axis of the shaft and also along the longitudinal axis of the shaft. At point B, we have a smooth journal bearing. So for the journal bearing, we only have a single support reaction perpendicular to the axis of the shaft. We also have to find the resultant of this distributed loading. Since it's a rectangular distributed loading, so the resultant would act in the middle. And for the magnitude of the resultant, we can find the area of this distributed loading. So it is 600 into the length of this rectangle, so 2. So it's 1200 newtons. Let's also label these support reactions. So this right here is AX, this is AY, and this is BY. So this is our free body diagram. Now we have to apply the equations of equilibrium to determine these support reactions. So my first equation is summation of moments at point A equals to 0. I am considering counterclockwise direction as positive. Since the line of action of AX and AY is passing through the point A, so these two forces do not have any momentum with respect to the point A. So AX and AY will not produce any moment about the point A. This 1200 Newton force is trying to rotate the shaft in clockwise direction about the point A. So the moment produced by this 1200 Newton force will be taken as negative. So we have negative 1200, and the moment arm is 1 plus 1, 2 meters. This support reaction By is trying to rotate the shaft in anti-clockwise direction about the point A. So the moment produced by this support reaction By will be taken as positive. So we have positive By, and the moment arm is 1 plus 1 plus 1 plus 1.5, so 4.5 meters. This 900 Newton force is trying to rotate the shaft in clockwise direction about the point A. So the moment produced by this 900 Newton force will be taken as negative. So we have negative 900. And the moment arm is the length of this shaft. So 6 meters equals to 0. So upon simplification, By comes out to be 1733.33 newtons. Now we have to find the support reaction AX. So we have summation of forces in x direction equals to 0. I am considering right hand side as positive. So we just have a single horizontal force which is AX. So AX is 0. Now for the support reaction AY, we can do summation of forces in y direction equals to 0. I am considering up direction as positive. So we have AY plus BY minus 1200 minus 900 equals to 0. So AY and the value of BY is 1733.33 newtons minus 1200 minus 900 equals to 0. So upon simplification, AY comes out to be 366.67 newtons. So these are our support reactions. Now with the help of these support reactions, we have to find the internal loadings acting on the cross section at C. So if I make a section through point C, and we can consider either side of this section for the further analysis. For the simplicity, I am going to consider the left hand side of this section, and if I draw it separately, then it would look something like this. This is the support reaction AX, this is the support reaction AY, this is the distributed loading, at point C we have a normal force, we have a shear force, and we also have an internal movement which I am assuming as clockwise. Let's label them. So this right here is AX, this is AY, this is the moment M, this is the shear force VC, and this is the normal force NC. This distributed loading is 600 newtons per meter. And these distances are 1 meters each. Again, we have to find the resultant of this distributed loading. So it would act in the middle. And for the magnitude of this resultant, we have to find the area of this distributed loading. So the magnitude is 600 into 1. So 600 newtons. And it is at a distance of 0.5 meters from the point C. This is the point C. So this is our free body diagram. Now we can apply our equations of equilibrium. So my first equation would be for the normal force NC. So my first equation is summation of forces in x direction equals to 0. I am considering right hand side as positive. So we have AX minus NC equals to 0. Since AX is 0, so NC is also 0. So this is our first answer. Now for the shear force VC, we can do summation of forces in y direction equals to 0. I am considering up direction as positive. So we have AY minus 600 newtons minus VC equals to 0. So AY is 366.67 newtons minus 600 minus VC equals to 0. So VC comes out to be negative 233.33 newtons. So this is our second answer. Now you can see that we are getting a negative answer. So the negative answer means that the direction we had assumed earlier for VC force, which we had assumed as downward, is incorrect. The actual direction of the VC force is upwards. So upwards is the correct direction for the VC force or shear force. So now for the internal moment M, we can do summation of moments at point C equals to 0. I am considering counterclockwise direction as positive. Since the line of action of NC, VC, and the support reaction AX is passing through the point C, so these three forces do not have any momentum with respect to the point C. So NC, VC, and AX will not produce any moment about the point C. But we have to consider this internal moment, which is clockwise, so we would take it as negative. So we have negative M. This 600 Newton force is trying to rotate the section of this shaft in counterclockwise direction about the point C. So the moment produced by this 600 Newton force will be taken as positive. So we have positive 600 and the moment arm is 0.5 meters. This support reaction AY is trying to rotate the section of the shaft in clockwise direction about the point C. So the moment produced by this support reaction AY will be taken as negative. So we have negative AY and the moment arm is 2 meters equals to 0. So we have negative M plus 300 minus AY, and AY is 366.67 newtons into 2 equals to 0. So upon simplification, M comes out to be negative 433.34 newtons meter. Again, we are getting a negative answer. So the negative answer means that the direction we had assumed earlier for the internal moment M is incorrect. Earlier we had assumed it as clockwise, but in actual it is anti-clockwise or counterclockwise. So this is our third answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the free body diagram or in the equations of equilibrium, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.